Welcome students. Now when we are aware of what determinants are and how they are to be evaluated, in this session we will be discussing the properties of the determinants. There are 6 properties. We will be discussing each of them one by one and we will be verifying them. Okay, going through the first property, it says the value of the determinant remains unchanged if its rows and columns are interchanged. That means first row is converted to first column, second row to second column and third row to third column. So according to the property, if we do that interchanging of rows and columns, the value of determinant will come out to be same. Let us verify it through an example. You can see I have taken a determinant of order 3 and it is expanded through R1. By now you must be aware of how to expand a determinant. So we will do the expansion quickly through first row. So the first element in first row is 2, hiding its row and column. This is the minor matrix determinant obtained, and its value will be 0 into minus 7, which is 0, then minus 5 into 4, 20. Okay, then moving on to the next term, because its position is 1, 2, so 1 plus 2 is 3, which is odd. So you know whichever term is at odd position, that element will be multiplied with minus 1. The one where the sum is even, it will be multiplied with plus 1. So minus 3 is at a position where sum of I plus j is odd. So minus 3 multiplies with minus 1. So this becomes plus 3. Now hiding its row and column, these are the 4 elements we are left with. So solving this determinant, 6 into minus 7 minus 42, then minus 1 into 4, 4. And then moving on to the next element, which is 5. Its position is 1, 3. So 1 plus 3 is 4, which is even. So 5 multiplies with plus 1. So it is plus 5. And then hiding its row and column, these are the 4 elements left in the determinant. Solving for this, 6 into 5, 30. Then minus 1 into 0, 0. Now further solving it, this is 2 into minus 20, which is minus 40. This becomes minus 46 into 3, which comes out to be minus 38, plus 5 into 30, which is 150. And on simplification, it reduces to minus 28. So our determinant has got value minus 28. Now we will apply the given property. We are interchanging rows into columns. You can see first row is converted to first column, second row into second column, third row into third column. You can expand it through any row or any column. For convenience, I am expanding it through first column so that we get exactly the same expression, though you can go for any row or any column. Now see, let us quickly discuss the sum of I and j for each of them. The position of this is 1, 1. So 1 plus 1 is 2. So even 2 multiplies with plus 1. This is A 2, 1. So second row, first column. So 2 plus 1 is 3. Okay, which is odd. So minus 3 will multiply with minus 1. Here, A 3, 1. Third row, first column. So sum of 3 and 1 is 4, which is even. So 5 gets multiplied with plus. So this will multiply with plus 1. This will multiply with minus 1. This will multiply with plus 1. So expanding it through first column. So 2, you hide its row and column. So these are the 4 elements left. Solving it, 0 into minus 7, 0. Then 4 into 5, 20. Okay, then this gets multiplied with minus 1. So we get plus 3 here. Now you hide its row and column. So these are the 4 elements in the minor determinant. 6 into minus 7, minus 42. Then minus 4 into 1, 4. Then 5 gets multiplied with plus 1. So it is plus 5. Hiding its row and column. These are the 4 elements left. 6 into 5, 30. Minus 0 into 1, 0. You can see the value comes out to be minus 28. So on interchanging the determinant, I named it as delta 1 and we could see its value is coming out to be same as the determinant delta. So there was no change in the value of determinant when all its rows were converted into columns or vice versa. Now moving on to the second property, it says if any 2 rows or columns, that means either you are only taking 2 rows or you are only taking 2 columns. So if any 2 rows or columns of a determinant are interchanged, the sign of determinant changes. So if initially the determinant was a positive real number or a positive expression, then it will get converted into -1 after going through, after the application of this property. Okay. So now this one I have generalized. Delta is the given determinant with first row elements A1, B1, C1, second row element A2, B2, C2, and third row element A3, B3, C3. You can see I have expanded it along R1 the way we did in the previous one. So A1 multiplies with this minor determinant, which is B2C3 minus B3C2. Then moving on to this, it will multiply with -1. So minus B1, hiding its row and column, we get A2C3 minus A3C2. That is the value of the minor determinant. Then moving on to the third element, it will multiply with +1. So plus C1, then hiding its row and column. The value of the determinant obtained, A2B3, then minus A3B2. So this is what I have evaluated the value of delta after expanding it along R1. Now we are applying the property. Apply the interchange of R1, R2. When we put arrow on both the sides, that means we are interchanging them. R1 becomes R2 in the new determinant, R2 becomes R1. So you can see in the new determinant, which is taken as delta 1, first row elements are A2, B2, C2, second row element A1, B1, C1, and third row elements A3, B3, C3. Now this one I am expanding along R2 so that you are very well able to see how one determinant becomes negative of other. Because I am moving from R2 now. These are the elements of R2. Position of this is 2, 1. Second row, first column. So sum of I and j is odd. So A1 will multiply with minus sign, -1. Position of this is A2, 2. Second row, second column. So sum of I and j is 4, which is even. So B1 will multiply with +1. This will multiply with -1. This will multiply with +1. And this will again multiply with -1 alternately. So in one element, if the sum of I and j is even, in the next it will be odd, and in the next one it will be again even. Okay, so alternately these symbols will appear. So I am expanding it along R2, this row. So first element of second row is A1, but because of its position, it multiplies with -1. So minus A1, and then hiding its row and its column. See, these are the 4 elements left in the minor determinant. If I solve it, it is B2C3 minus B3C2. That is what we have written. Then B1 multiplies with +1. So it is plus B1. Now you hide its row and column. So these are the 4 elements left. Solve the determinant. It will be A2C3 minus A3C2. Then moving on to the third element, C1, it will multiply with -1 because see, its position is second row, third column. So 2 plus 3 is odd. So C1 multiplies with -1 and it becomes -C1. When I hide its row and column, on expanding the minor determinant obtained, we get A2B3 minus A3B2. Now you compare both of them very clearly. You will see each of the term is identical, but they are differing by a negative sign. Compare these two. They are exactly the same. The only thing is here we have plus A1, here it is minus A1. Moving on to the next one. It is minus B1 which is multiplying with the rest of the term. Here it is plus B1. This is plus C1 and here it is minus C1 multiplying with the remaining term. So you can very well see delta 1 is coming out to be minus of delta. So whenever you are interchanging any 2 rows or any 2 columns, then keep in mind you need to change the value of determinant by a negative sign. It will differ by a negative sign.